Good evening. My name is Azam Khalid, and today I will be walking you through this guide for Sierra. Sierra is a visual query interface for Neo4j databases, helping users build Cipher queries without actually writing any code. Instead of manually programming queries for your database, we can use Sierra's graph to form them visually and intuitively. Alright, now that we are in Sierra, the first step is to connect to your Neo4j database. You can do so by going to the top left corner here, choosing the database option, and clicking Connect Database. This will bring up a pop-up where you can enter your database credentials. Once you press OK, after a brief loading screen, and a connection will be established to your Neo4j Aura server. Before we move on, I quickly want to explain the difference between a node's entity name and ID. So here we have two nodes, order and product. The node name of this node is order and of this is product. However, if we look at the Cipher query box here, you will see two variables A and B, which are mapped to order and product respectively. How this works is if you hover over a node, then it will show you the variable for that node. And the variable is basically a unique identifier for a node. As you can see, the same thing is here for product. And this means that if I go to the order and create a predicate for it, let's say order ID, then in the query, this will be not written as order.order ID, but rather a.order ID, because this clears many ambiguities in case two entity nodes exist in the graph. Now that we are connected to our database, let's start off with some simple querying. We can click the New Node button to add nodes, which brings up this pop-up where you can see all the entities or nodes and also preview their schema. I'll go ahead and add the person node. As you can see, this is the person node. And suppose I want to, as an example, find all the people that were born after a certain date. I can click on the node to open the node sidebar. And this is where you can edit all the properties and add aggregations for your node. I will go to the properties section and click on the born property, and I can select a value, let's say 1964, and I can also change the comparison operator. Let's change this to after 1964. I can go to the Cipher query box, and here you can see the query that we have formed visually transformed into the Cipher query language query. If I press the play button, then I can, in this pop-up, see all of the outputs of the person node that were born after 1964. Let's move on to relationships. If I add a new node, let's say a movie node, and then I drag from person, then drop to movie, this creates a line which is known as a relationship in Neo4j. And if we click on this line, it will bring up the relationship sidebar. And you can choose the relationship type as well. For example, I can choose reviewed, and it will show in the corresponding visual field and also in the Cipher query translation box. Now let's take a look at the path length feature for relationships. Path length or hops in Neo4j is basically the amount of nodes that you traverse to get from the source node to the target node. If we go to the relationship sidebar, there is the cardinality option where you can change the number of hops. Right now it's set to a discrete value of 1, but we can change that using the slider to 2. And I can also enable the return path length button so that we can see the path length in the output. You can see in the graph that a new kind of capsule has been added, and on the tooltip it shows the number of hops and it kind of explains what the feature is. If I press play, the output is between two people, and this means that this person and this person are indirectly related. They do not have a direct relationship, and the path length is 2. Now another feature is you can change this from a discrete value to a range. Now it becomes from just the path length of 2 to 1 to 2. And the capsule has changed as well to accommodate this. And now if you play, the first three are of path length 1, which were not visible in the earlier query. And the last one is the one that we saw previously. In Neo4j, relationships have their own properties, separate from a node's properties. To edit them, you can click on the Edit Relationship Properties button in the Relationship sidebar. This brings up a menu where you can change the path length, the selected properties, and also add new properties. For this demonstration, I will add a summary property equal to any value. Click on Add Property, and also I will add a rating property, and this time I will choose not equal to with a value of, let's say, 100. Another thing to note is I can change the color of the predicate bubble as well. After clicking Save, the graph updates, and you can see that the relationship properties are actually embedded inside of the path length box. And this will keep expanding the more relationship properties you add. And when I press play, you can see that only one relationship between person and movie matches this criteria that we had selected. I will now demonstrate the aggregation feature. We are currently in a product order database. If we go to the aggregation section of a node, we can click on Add Aggregation, and suppose I want to find the sum of unit price for each supplier. I can do so by selecting Sum here and then choosing the unit price column. I can also add an alias, let's say price sum, and I want to group this by supplier ID. If you go ahead and run this, you'll see that supplier ID and price sum are both here. So basically, you can see the averages grouped by each supplier ID. Another thing I wanted to quickly mention is the design choice that we have taken to represent simple aggregation. Basically, everything that is inside of the node will be appended to the return statement. So as you can see, all of these are returned separately, and it is intuitive in the manner that everything that has a black border around it will get returned. For example, if I toggle the return on the node, it no longer has a border indicating to me that it won't be returned, but all of these do have a border, and these are not filters. The predicate bubbles are more like filters, and they are on the boundary because they leave out some things and return other things, but those that are purely just return statements or return clauses are appended on the inside of the node. Let's move on to a more complex form of aggregation. To start off, I will do the same thing. Let's say I want to find the sum of all the unit price, and I will group this by category ID. If I run this, then this will show me, first of all, the category IDs and also the sum of all unit prices for them. So the value varies quite greatly. Some are 400 plus, some are 160, and so on. So let's say I want to filter some of these results. I can click on the pipeline button here, or more the filter button, and it is required to add an alias. I'll just do sum price. We can do greater than, equal to, not equal to, less than. I will do less than 200, and I will need to add an alias for category ID as well because of cipher query syntax. Now when I run this, you will see only those two that were below 200 have returned. And if you look at the cipher query box, this additional where clause, where some price less than 200 has been added, and this is the pipeline or filter aggregation. Another thing worth mentioning is the representation of pipeline aggregation. As I said before, this filters something so it will be present on the node's boundary. However, if the simple aggregation, then it will be inside the boundary, but for pipeline, it's on the boundary, which matches the predicates, which are also on the boundary. Now we have another scenario here between an order node and a product node, as well as some predicate bubbles, ship city, ship name, and on product side discontinued. Now one thing you will notice is that when you add these predicate bubbles in the cipher query box, you will see that these predicates are being ANDed together. This means that there is an implicit AND operation between each of them. To change this, however, we need to go to the toolbar ribbon, and this option lets you select which operation you want to link two predicate bubbles together with. So I will choose OR link here, and there are two modes to this basically. The first is you drag and drop two predicates, and this creates an OR group. In the cipher query box, you can see the ship city is ORed with the ship name, and discontinued is ANDed still. This creates an OR grouping, or as we like to call it, a sunflower. And if you click on this button, then it will bring up the sidebar where you can remove the OR group. And if I execute this right now, it will basically work as intended in the cipher query. I will go ahead and remove this. And the other mode is basically from one node to another. If we add an OR between two predicates of different nodes, then what happens is there is this slanted line, and when you hover over it, it shows the OR group in random colors. And cipher query also reflects this. If we play it now, then we see that the number of outputs has changed because the query is different this time. Another operation is the join. We can go to the toolbar and select join. And to join two predicates, what you need to do is drag and drop like shown previously. What this does is create a dotted line with an operator in the middle specifying that this is a join. If you click on the operator, it pulls up the sidebar so we can see what type of join we want. The equi join just simply compares two values, but there's also the tier join where we can choose the operator for comparison. For now, we will just stick with the equi join. If I run this query now, you'll see that all of those city will be Berlin and ship city will be Berlin as well. And in the query box, actually, you can see that there's a new clause where a.city is equal to b.shipcity. So this is our actual join. In the join view, basically shows joins between two nodes in a neat manner, and also it has warnings for whether your nodes and joins between them are valid or not. For example, if I remove this link, add another predicate with a random value, and then join this random address to the ship city, you'll see in the join view box that we get a no matching values warning. And also there's this list button where we can see all of those with errors or just edit in general. Now let's move on to more complex query formation. In a node sidebar, you will see the selected predicates column and also a change nesting button, which if pressed, will bring up this menu with quite a lot of options. One thing you can do to form complex queries is click any of these operators between these nodes, and the node after the operator will be affected. So in the cipher query, we will see that the product name is ORed with category ID, and this follows the not and or precedence. I will change this back, and suppose I want to or a subnest or a grouping of predicates. I can do this by going to the change nesting menu and using the indent and outdent buttons to create an indent. And also I can now change the operator for the whole group inside to an OR. As you can see, I have gained what I wanted basically. And if I play this, then you will see that I get only one result, which is what I wanted. I've now reverted the changes to the nesting to show you the expression tree feature. Basically, and and or operators are binary operations, which means they are perfect for representation on an expression tree. And this is basically a much more graphical way or visual way of doing the same thing as above, but with more added utility as well. So clicking on the operators toggles just like before, and the nesting level is indicated on the top left corner. For example, if I increase this, then you can see it goes from 0 to 1. And it's easy to form queries on this, and you can also rearrange the position of the predicate bubbles. And if I just form an example query here, you can increase the nesting of an individual predicate bubble or of the whole subgroup under that operation. Since the expression tree feature is a bit complicated, I'd like to demonstrate using an example. Here I have a movie node with the predicates title as the matrix is loaded, release date as 1999, and votes greater than 274. If I execute this query right now, The result is no results found. We can change that by going to the change nesting to allow for partial mapping using OR operations. In the expression tree, basically any operation that you see is represented in the form of a purple or an orange circle. This circle means basically that the two predicate bubbles under it are being ANDed. And if I change this to an OR, what should happen is that the pink and the yellow nodes should form an OR grouping. As you can see, it indeed did form a group, and it shows that in the cipher query result as well. Now, if I change this as well, then the whole thing becomes a singular or group. However, I don't really want that. So what I can do is I can change these, the title and the release date to OR, which means that it is either the matrix reloaded or it was released in 1999. And to solidify this with an AND from here, I can change the nesting using the sliders here. What this does is it will create a bracket. So this is our OR clause combined with our AND clause. And if we want, then there's also a shortcut for the operators. This basically means that the slider on everything under the operator will be indented or outdented. So for in this case, everything under it, that means the pink and the yellow node will be indented, and for this, everything under it will be indented. So all the three nodes will be. And now if I go ahead and execute this query, you will see that we only get one result, which is the matrix reloaded. However, if we were doing it by default as an OR group, then we would get all the other results. Now let's look at an essential feature that you will certainly use for almost all of your queries in Sierra. If you go to the toolbar up at the top here, there is this edit button. If you click it, a query controls pop-up will show. And there are quite a few options here. I will go over them one by one. Basically, there's the return option. If we go to the product node, you hover over it, and then you will be able to see the product code. So that is the thing that we will be referencing. The product code is A. If I want to return the unit price of A, I now can also make the return distinct with a skip 5, so skip the first 5 values, and also limit 5, only 5 values. And also I can order it by the same property of unit price, and this is for ascending. I will choose descending, and I click update query, and in the cipher query box, everything is here. Our distinct clause, our order by, descending, and skip and limit. Once we press play, we will get the intended outcome. Now let's take a look at how query control clauses are represented visually in the graph. First up is return. To add a clause, first I need to look at the product's variable. In this case, it's A. I will write return A.unit price and update query. You will see a small bubble appear inside of the node. When hover over, it says the return clause, and it has the boundary, dark boundary on its border, indicating that it will be added to the return clause, which is indeed the case. And this fits quite nicely with simple aggregation, which I will demonstrate later. Moving on to the order by clause, I can order by A.product ID ascending, update, and this time we have a red colored up arrow. If I add another one, let's say A.category ID, this time descending. This is a blue descending downwards arrow, and all of these are color coded so that you can immediately recognize from a distance in the graph, if you are zoomed out, which is which. And as I mentioned earlier about simple aggregation, if I add a few aggregation bubbles, you will see that these grow from the top to bottom. However, the query controls grow from bottom to top. They both occupy a shared space, indicating that they are all just added to the return clause. However, they also have their own systems adjacent to each other, which are completely separate and easy to use. Another handy feature is the clipboard. On the toolbar ribbon, if I click on the clipboard button, then you will be able to see the history of all of the queries that you have executed. each of them with syntax highlighting, and also the time so you can keep everything organized. I myself have a lot of queries, around 90 to be exact, and some of the things that you can do here are you can star a query. I have already one query starred. Another handy thing is you can click on this restore query button. If I click on it, then it will restore the query into the editor and into the graph. Let's try another one. As you can see, this one is quite different. And if I go to start queries, I can restore that as well. And I can also delete queries which were not useful for me. Now let's take a look at a feature that could help you immensely in Sierra. Let's say, for example, I want to join these two nodes, and also I want to add an OR link between these two nodes. Immediately you can see that this is getting kind of complicated and clunky. The labels for it are even in not good positions, and if I want to add an edge between two of them, then this would only create more confusion. A better way is to remove all of this, go to settings and enable reduced edge crossings, which moves link predicates to the top to reduce edge crossing. When I enable this and move out of the settings, now when I make an OR link or a join between two nodes, see, look at what happens. The two nodes automatically get pushed to the top or the bottom, and this way you're free to form relationships. You can use whatever features you want, and you can basically be assured that between two nodes there will never be anything that crosses the relationship or anything horizontally, because all of these nodes will be free from overlaps. Now I want to demonstrate the capability of Sierra by tackling on some advanced query formations. So we're given a movie database where we have to write a query to find all people who are connected to movies through either one or two reviewed relationships, and include only those results where the person was born before 1996 or movie was released before 2012. Exclude any review of the reviewed relationship which has the summary "You had me at Jerry" and return the person, the movie release year, and the total sum of votes for the matched movie label as votes. Okay, so let's get started. First of all, we will need a person node, and a quick tip: you can go to the sidebar and see possible targets, which means outgoing relationships from that node exists. I will just choose movie from here, and we have our relationship already. I can go and choose the relationship as reviewed, as stated, and then I will change the path length from discrete to range and from 1 to 2. Then I can edit the relationship properties. What was given to me was that the summary should not be equal to "You had me at Jerry." I will add that property, click save. So things are going well so far. Now I also need to add the criteria in the form of predicates. I can choose the born and should be before 1996. The same thing for movie. The release date should be before 2012. And it says there needs to be an OR between them. Okay, that is our OR link. And the final thing is the aggregation on movie, because we need the sum of the votes. I click on add aggregation, then this is sum, then votes. I can add an alias, which would be vote sum per release. I can group by the released. Let's execute this query. Okay, so these are the people that match the criteria and their release date, and also the vote sum per release, which is what we were looking for. Now let's move on to the second query, which in my opinion is a bit more complex, but we'll go through it step by step. We're given in an ordered database, write a query to find products connected to categories and include products where the quantity per unit is not 36 boxes or the unit price is not 12.5 and the product belongs to category 7. Ensure the matched category is also category 7 and ensure the product and category have matching category ID values. Return distinct product category pairs and sort the results by product price in descending order. As well, limit the output to the top 10 results. Okay, we are in the orders database. I'll start again by adding a product node and using target feature to add the category as well. We actually need quite a few predicates for the product node, one of them being the quantity per unit being not equal to 36 boxes. And then the unit price should not be 12.5, I think. And finally, the category ID should be 7. On the category side, it's a bit simpler. We just need category ID 7. On the toolbar, I already have the join selected. I'll just drag and drop directly from one category ID to another. We have our join here. And we actually need to change the nesting for this node to achieve our actual intended query. And to go ahead and do that. So there's two ways, first one and second one. I'll actually choose the expression tree one. For this, we need to change the operator between category ID, unit price, and the quantity per unit. So this one should be toggled. We need to increase the nesting for category ID and also unit price. You can do so easily by matching the colors or basically using the quick nesting feature. And you can see it's getting quite complex, but it's not finished yet. We need our query controls. We need to return distinct limit 10, also order by a dot unit price descending. Click update query and then play. And yes, we get the correct result, which matches our quite complex criteria. Thank you for watching this demo video. If you want to try Sierra for yourself, please click on the link as shown on screen or in the description down below. Thank you.